Alright, Chapter 9, Miscellaneous Items. The following discusses items not specifically demonstrated with a design example. Fixing bad pad exits. Common error of the bad packs over the error. The most likely precovers over the trace is leave with the bad. Offsetting of the trace has a jog in its inside of the pad, and shown in the example of the bad pad exit the color enhanced the corresponding error mark spreadsheet. Problem jog inside resistor 2 pad 2. Fix a bad exit error with a manual add or edit route mode. Select with the trace. Select trace. Use the control left click, right click. Use the unroute segment to unroute the trace from center of the pad to the V to make sure that all the segments manually. Reroute the tracing with the resistor 2 pin 2. Click with the resistor 2 pin 2 starting route. Run the trace straight down. Leave with the pad in the center. In perpendicular, check with the mouse just as path of the resistor 2 silk screen outline. Place with the vertex. Right click, select finish, and then force the jogs to be placed outside of the pad, shown in figure 9.146. Alright, design, cache, cleanup, and replace update. Every project with a capture the design with the design contains a design cache. At some point during the design process, you will be likely confronted with having to modify the design cache, whether directly or indirectly. You need to use one of the three cache commands. The difference between these commands subtly used rarely begging. Circumstance of however the wrong command can unintended result of the purpose section has to explain the difference of the command examples, explain when and how to use them. Design cache contains a list of all the parts added to the design and the parts that have included the template that was used if any of the project was originally set up. You can view the design cache of the project manual of the figure 9147, in which parts of the design cache is listed in place bar drop line with the menu bar, which makes it easy to find additional parts. When you place a part with the actual, use the local part copy of the part with the library, not the part itself. However, the capture makes it link between the copy of the original part. If the part in the library is changed, or if the local copy is changed, the capture librarian will know about it and break the link. Figure 197, 147, design cache list of place parts. If you change the part on the schematic page of the modify with the give the new name of the extension, such as _1 added with the name of the indicator with the blue arrow of the figure 9147, is no longer linked to the original part in the library. If you change your mind of the need to give the original part back to the capture, replace with the part design cache folder with the original part library. To replace with the part in design cache, select with the part with the project manager, the design cache folder, replace with the cache with the from the design menu. Use the also replace with the cache function in exchange with the existing part with one of the same or with a different library. For example, the 74LS00 and or gates for the 74AC200 and or gate exchange op amp that was for the linear technology library from one of the analog device library, vice versa. Alright, the original part of the library is chained with the try to play with any of those of the parts design capture library and chain with the difference recommended that you update with the cache with a new part but you don't have it, you don't want it. Update the project design cache, select the part of the project manager design cache folder, right click, update cache for the pop-up. Capture library will not catch the difference between model library part, modified project part because the names will be different by an _1 or similar. Capture librarian will ignore it. If you perform back annotation layout with a part within the design will likely contain the properties and if you will not want to lose. You want to change the part with the replace cache command, retain the properties, preserve the schematic part with the properties option in the replace campaign dialog box. If you place deleted parts several times with the design cache will leave the unused part that does not really cover the problem. Cumbersome of the continue looking for the unused part, looking at the one of interest. Clean out unused parts from the design cache. Select design cache folder project window. Right click, select clean up cache from the pop-up. Add testing points. There are two approaches to adding testing points to the board. First approach to add a test point with a part schematic designed with a single pad footprint to place on the board and layout as well with any other part. Second approach is to have the layout placed for the test point with a net with a test point that can be annotated with a capture of the property spreadsheet. It will not be displayed with the schematic. The later approach is described in here to place and serve the test point in the inline with the trace and figures in 9148. So 148 show the test point placed on the net in the layout. First, define a pad check with the test point on the pad check with the spreadsheet with the one of the unused V with the construction of the con, so some pad check with the scratch save with the user layout library figure 149 150. You can play with the test room with the manual routing and have the layout places all the test points with it. One's test manually, two with the one over the manual routing, two with the test point. Be added the routing net with a case for the trace must contain at least one vertex after the completed routed. To select the desired net, right click, add to the point with the pop-up. To have the layout automatically place test if the trace must be routed to it first, and then select the place test point with the auto menu. The test point will be placed on all nets that were 149, so surviving the Viva as a test point. And then you have the test point. It is edit name, net name. Some of the test point has the test point and pad stacks assigned to them. Move them. You can move them or delete the test point. Manual routing tools. Alright, top itself, the auto engineering change order. There are several different types for the auto engineering change order that can be run on the correct engineering change order run. Depends on what you want to update with the components of the NAS, whether you add or delete the update, whether back annotation previously performed with layout or capture, and how recently figure 915 show the general effect of the components of the layout with the engineering change order table, and figure 916 show the effects of the net traces, and layout. Figure 917 explain with the color scheme. 915 effects of the components of the engineering change order. 916 effects on the net trace of the engineering change order. And 917 effects engineering change order effects legend. Alright, making tables explain the effect of the tables come out with the information provided with the layout user guide and lay user guide PDF that has reorganized the bridge readability effect of the text of the obstacle amended with the table sense of there was never effect with the engineering change order. Net attributes the auto engineering change order was omitted because it communicates information between printed circuit boards for more information. Auto engineering change order, see page 35 of the layout user guide PDF. Alright, making a custom capture template. If you design a lot of projects similar to each other, setting up the project template and the capture may be real time so that it can eliminate error the reviewing known good project setup. Project templates can be used only in setting up project through analog or mixed analog digital ops for the new project dialog box. Or the simplest you can make with a PCB design, either analog or mixed analog digital option or the PC board wizard option. You can still advance creating your own capture templates for the PCB design projects. To make a custom capture project template, to start the new analog mixed analog dialog project, set up with power supply, ground supply connectors, whatever you want, and then save it into the Orcad tools capture template PSpice full of the other templates automatically will be added to the template list so you can select the next one next time you start the new project. Making custom layout technology template file. As your current capture templates for the design on the PCB similar to each other, setting up with a custom technology file and save a lot of time can eliminate manufacturing errors resulting using the new good PCB setups. Make a custom technology file, the TCH template or TPL reusable PCB design max file layout. Begin with a known good board design. Save the board design with the desired file as a TCH or custom technology template or a max layout with the data folder, the folder of your choice. The file next file will contain all the elements of the good board, including layers, stack up, pad definition, board outline, trace width, and spacing, etc. You can save the reuse the source all the design board elements, including the board outline connectors. Delete unwanted elements, selecting them and deleting them. It will likely want to delete all the not except for the made with the ground power nets. Delete the nets open with the net spreadsheet. Select the nets for the nets to delete. Hit delete key on the keyboard. You can leave the power ground nets so that consistently review the capture template will give the layout with the template preserve all ground power net names assignments of plain layers which are preserved in the layer stack up. So modify the file. Note when you save the nets and template import ones the same with the name of the new as the MNL. Netlist capture layout will take two nets to duplicate the names of the marked, but the imported ones with the dark yellow color, so they really the same net, but they can delete the new one with the dark yellow color if the previously established color scheme for the net. Okay, the next time you start with a new board, select the template with the TCH, TPL, or Max file with the auto engineering from auto engineering change order dialog box instead of the U, the default TCH, or in one beta any technology template. Alright, using Stack Up Editor. Stack Up Editor is new to version 10.5 and invoked for the main layout session. Modify the renewal existing technology template file can be invoked from Hector board design made. Modify the layer property. Stack Up Editor can be used to add, delete routing plane layers, change order layer name, define border technology types of cores and built up, specify core prepeg property thickness, and and copper layer properties, name, thickness, and conductivity. Solder paste size is relative to the pad size. Solder mass properties, wet and dry, and ER. Special overall board thickness, specified board impedance and ohms, specified Viva protection, non-tent plug caps, and specified document layer and insert with a stack-up drawing. Alright, using a stack-up editor with an active board design, stack-up editor will demonstrate either the modify the stack-up with the analog with the design example of 1, and recall with the analog design example the second ground plane was added to the design with copying existing ground plane, creating a new ground plane 2 is indicated in figure 9, 152, ground plane 2 was replaced at the very bottom of the layer spreadsheet with the default stack-up editor must be with the ground layer 2 with the very analog design example of figure 1 at the bottom of the layer spreadsheet to the actual position of the stack-up. Figure 9, 151 show the layer spreadsheet before stacking up editor. Alright, to evoke stack-up editor with the active board design max file, select with the stack-up setting options menu, stack-up editor shown figure 9, 152. Stack-up editor adds the technology, solder paste, solder mass, silk screen, bottom solder paste, solder mass, silk screen, top and bottom foil layers, advanced option drawing layer, view with projection, cross-sectional view, border thickness, and then the quick pictures on the side. To move levers up and down so that you move the left click once, then you move up and down arrows of the right hand and left hand. Figure 195, 3 layer spreadsheet, active design of the ground layer around 2. You're not going to use stack-up editor, delete, add layers, deleting a layer, and select the layer that you want to delete with the delete button. Stack-up editor toolbar, deleting a layer. Stack-up editor does not delete it from the layer spreadsheet, but only change the layer type that you use. To add routing layers, press insert layer button. To add planar layer, press the insert button. After you've added the layer, you can change its property. Change property conductor laminate layer. After conductor laminate layer, press button I. Use the dialog box, specify layers, new properties. You can add stack-up a drawing with the PCB design, engineering documentation to aid with the board, manufacturer fabrication model board with the stack-up the drawing shown next to the board with the design figure 154. Stack-up information saved with the file that is associated with layers, stack-up building drawing is placed. Stack-up a drawing is automatically generated by a stack-up editor with the insert of the PCB design non-electrical components included with the post-process Gerber files to specify the post-processing setting. Submitting stack-up drawings on the Gerber file as a stack-up drawing cannot be back annotated capture. To add stack-up drawing to the board design, choose one of the document layers from the drawing layer drop-down list. See the left corner of the figure 9, 152. When you click OK for the setup of the drawing, will add with the board design. Know that you will have the zoom out to see it. Then you'll have the document layer with selected visible. You can change the color and clear the setup of the drawing by changing the color layer in which it was assigned, clicking the color settings button on the toolbar. To move the stack up the drawings, select with the component tool with the left click with the drag with the selection box across the stack up the drawings to select it, move the drawing in the new location, left click until to place it. If you don't want to stack up the drawing visible, you can either turn off the documentation layer, reside with the detail of the stacking of the drawing. If you choose to delete the drawing, you can delete it. Stack up the information, just delete the drawing, delete the stack up the drawing, select with the component tool with the drag across the stack up drawing itself. If you select it, hit the delete key on the keyboard. You will be asked if you want to delete just the drawing or both the drawing or stack up information from the board. See figure 195. Alright, using stack-up editor to set up custom technology template file. Use the stack-up editor mount for the existing technology template file. Use the set up a new custom technology template file with using existing start black to make a new change template file with a stack-up editor. Invoke stack-up editor with the maintain layout session window with the design window by selecting the divine stack-up of the tools being created. Edit stack-up the dialog box and select. Baseline stack-up, click over the browse button, select with the TCH or the TPL file. Predefined stack-up text box automatically filled with the selected file with the open file with dialog box. Click OK, create edit stack-up dialog box. Display the stack-up editor. Use the tools described above the modified stack-up properties inherited with the baseline technology file. Use modification and complete. Click with the save as button to save the new technology file with a new name. If you click the save button instead of baseline technology, if you wanted to change the new setting, make sure you press the right button. If you don't want to modify the original file. Submitting the stack-up drawings with the Gerber files. Submit a layer stack up the information the board manufacturer can include it with the Gerber file that's described above. The stack up the typically play with the documentation layer. Include with the Gerber files, you must use the documentation layer include with the post-process listings, include the assembly layers at the top and ASB and the fabrication layer with a note that you can use the other documentation layers, silkscreen, etc. But assembly fabrication layers are probably more appropriate with the target documented layers. Select the drawing layer drop-down list on the stack-up editor, lower left-hand corner, figure 1952. When forming the post-processing, make sure the layer contains the stack-up drawing is enabled. To enable the layer, select post-processing settings, the option menu, batch, enabled yes. When you perform the DRC, the stack-up of the drawing, the error of the produced error because of this component is outside of the board outline. You can ignore the error, open the error markers, spreadsheet, place the spacing errors, right click on the mark as good design rule check from pop-up menu. Alright, adding solder seeds. Solder thieves for the surface mounted devices will have wave solder and straightforward solder thieves that construct the copper area with the top layer of the board behind the layer setup that they lead on an integrated circuit with a small solder mask opening over the pad exposed into the solder to allow adequate placement resolution. You'll need to set with a detail grid at least 1 mil. Selecting a system setting of the option menu, the detail grid X and Y to 1 mil. Place solder to the pad. Select the obstacle tool. Right click with the workspace. Select with the new right click with the property of the edit obstacle with the dialog box. Select copy over the obstacle type. Obstacle type list with the width of 1 mil. Select with the top from the obstacle layer list with the attachment as to non-drill box to the correct size. Same size, slightly larger within solder pad with achieving and thieving them from the correct location shown in figure 5.3. Right click with the select the finish for the pop-up menu box is completed. To expose the copper area, select the object tool with the right click with the new right click with the again select property to edit obstacle with the dialog box copper area from obstacle type list with the width of the 1 mil. Select with the solid mass. Solder mask top for the obstacle layer. Leave it with an attachment and then drop the box of the pad drawn as a previous step. Right click finish for the pop-up. The box is completed. Alright, printing a foot pad of the PCB design. You can print a catalog footprint of the PCB. The design gives you the opportunity to review the package for the design. Footprints are printed with the scale as you conform in a dry run to make sure that all the parts fit with the footprints before you have the board fabricated. Especially helpful if someone else had made a custom footprint, wanted to verify that it would be correct. The directions creating with the printing catalog are provided in Chapter 15. Layout, user guide, search catalog. Tool of direction very straightforward, so they will not be duplicated here. This page is intentionally left blank. And we've moved on to Chapter 10, Post-Processing Board Fabrication.